friends, in our last session we were discussing about single period inventory models. We discussed the concept with the help of one very popular example, that is newsboy problem, and here we discussed that this newsboy has only single opportunity to procure newspapers in the morning, and whatever is available he has to fulfill the demand in that particular day, and there is no second opportunity given to him for purchasing the additional quantities, and whatever is left over will not be carried forward to the next day. And this is a very common example in variety of situations where you have only single opportunity to procure, and with that quantity you have to fulfill your entire period's demand. Now, when we were developing this model, we came across the concept of expected profit, and we discussed that we want to procure additional units as long as our expected profit is increasing. We want to maximize our expected profit, and expected profit is directly dependent on the quantities which you are stocking. So, we discussed two types of cost. One is the excess cost, another is the shortage cost, cost of overstocking and cost of understocking, and we discussed with the help of a diagram that we want to create a balance between these two types of cost, cost of excess and cost of shortage, or cost of overstocking and cost of understocking. So, you can use any of these terminologies. Now, there are two types of situations which are possible in this single period inventory model. One situation where your demand is varying continuously, or your demand is discrete in nature. So, these are the two situations which are possible. In the last session, we had one example, and we will like to complete that example by discussions of the solution and by the concept of discrete and continuous inventory management. Now, in this particular example, we see that demand is varying uniformly between 300 liters to 500 liters per week. Now, for handling this continuous type of situation, we discussed the concept of service label, you remember, in our last session. Now, here the demand is varying between 300 liters to 500 liters per week. So, this is not as simple as the case of newsboy problem, that also we will discuss, but right now we are discussing the example of continuous demand. So, this problem is dealing with continuous demand, and here this demand is varying uniformly between 300 liters to 500 liters. So, the graph of varying the demand is like this. This is 300 and this is 500. So, from 300 liters to 500 liters demand is varying uniformly. All levels of demand, maybe it is 301 or it is 499. All these levels of demand have equal probability. The meaning of this statement is that all these levels of demand have equal probability. In some other situation, in some other case, it can be given to you that demand varies normally between 300 liters to and 500 liters per week. In that case, the curve will be like this. 300 liters to 500 liters demand varies normally. So, depending upon what type of language is given, what type of your experience is there, you can have a distribution curve of the demand in case of continuous demand. Here it is uniformly So, this particular situation is applicable, that demand is having the all levels of demand have same level of probability. If it is normal distribution of demand, all levels will not have the same level of probability. Some levels will have higher probability and some levels will have lesser probabilities. Now, some cost parameters let us see. So, here let me remove this particular case where we have the normal distribution curve, it may create some kind of confusion. So, let us not have this normal distribution curve, and we will like to go with our uniform color. Now, here Cindy pays 20 cents per liter for this product and charges 80 cents per liter for it. So, the cost price is 20 cents and the revenue, the selling price is 80 cents. Unsold products has no salvage value. So, this is no salvage value. If there is right now, you understand, with this we can calculate the excess cost and shortage cost. Now, the excess cost is the cost per unit. Here it is 20 pounds, $20 or $0.2 or 20 cents. Since salvage value is not given, so it is only 20 cents. For an example, some salvage value, if let us say salvage value is 5 cents per liter. In that case, CE will be 20 cents minus 5 cents, that will be 15 cents per liter. But since salvage value in this is specifically written that unsold product has no salvage value and cannot be carried over into the next week due to spoilage. So, here the CE is our 20 cents per liter, that is the excess cost. The cost of shortage, the profit which you are not able to earn, that will be revenue minus the cost price. 80 cents is the revenue and the 20 cent is the cost price. So, your 60 cents per liter is the cost of short supply, shortage, cost of understocking you can say. So, these are the cost parameters. Maximum demand is 500 liters per week, minimum demand is 300 liters per week. Now, let us see how are we going to solve it. So, we have these parameters, already we have calculated these parameters. Now, the service label is, if you remember, we have already discussed the formula of service label in our previous session. So, that is cost of short supply divided by cost of short supply plus cost of excess supply, and that is we have already calculated these value 60 and divided by 80. So, the service label required in this particular case is 75%, 0.75 means, or you can write it as 75% label. If you operate at a 75% service label, you will have maximum expected profit. The meaning is that you should not try to fulfill, the meaning is that our demand is varying from 300 liters to 500 liters, demand is varying from 300 liters to 500 liters. So, there are equal probabilities, as I told you from this graph, for different levels of demand. 300 liter will also have the same probability and 500 liter will also have the same probability. Now, we want to fulfill, for an example, what is the meaning of service label? If I want to have 100% service label, if I want to have 100% service label, that means I am always ready to fulfill 100% demand, and 100% demand is 500 liters. So, every week I will stock 500 liters of products, but this particular calculation says that you should not try for 100% service level. The 75% service level is the most optimal level of service level for your organization. So, you should have some stocking which is less than 500, and this is 75% of the amount of the maximum stocking level that will give you the full fledged you can say profit or the maximum expected profit. So, the answer for this question is, thus the optimal stocking level must satisfy demand 75% of the time. You should not try to fulfill 100% time of the demand. You should be satisfied with 75% of the fulfillment of the demand, because it is going to give you maximum expected profit. And for the uniform distribution, will have equal demand plus 75% of the difference between maximum and minimum. So, the minimum demand is the 300, and out of the distribution from 500 to 300 we are taking 75% of that. And again going back that curve, this is your 300 label, this is your 500 label. So, you are fulfilling this 300, and out of this, this is the 75%. So, this is the entire area, from here to here it is 200, and 75% of 200 is 150. So, 300 plus 150, that makes 450 liter. So, you are going to stock this quantity, that is 450 liters, and this is going to maximize your expected profit. But you are not stocking 100%. You are stocking only 75% service level you are fulfilling. So, there are chances that 25% of the time you may run stock outs. 25% of the times you may not be able to fulfill customers requirement. So, there is no problem as long as you are able to achieve higher expected profit. Even if you are not able to fulfill customer requirement for 25% of the time, do not worry, but this calculation helps us in deciding more scientifically. Otherwise, intuitively we feel that we should be able to fulfill our customers requirement for most of the time. So, that will push, that will encourage us to stock as much as we can. We will like to stock 480 or maybe sometime 500 also, but that will not help us in improving our performance with respect to expected profit. So, this scientific method helps us even though some demand will be unfulfilled, but it is not going to benefit in our increase in the expected profit. So, that is the case of uniform distribution of demand and uniform and continuous distribution of the demand. Now, let us see the case of discrete distribution. Let us see the case of discrete distribution. Here you have different labels of stocking. Here you have different labels of stocking, and here you are seeing that we have step by step labels of stocking. Now, here the question is to stock at the next higher label, so that we can maximize our expected profit. So, now let us see how to use this formula in that particular case. Here we take an example, and it is similar to that newsboy problem which we have already discussed in our previous class. We have, let us say, different labels of demand 10, 20, 30, 40, 50, 60, 70, and these are some product, again you take it is newspapers, because model is popular by newsboy name. I will assign different labels of demand, different labels of you can say probability 10, 20, 30, 40, 50, 60, 70 are different levels of demand. So, if you see this diagram, so these are those different levels of demand where you are going to decide that this is let us say 10, this is 20, this is 30, this is 40 and so on. So, these are the different stocking labels and I have given the probabilities to these different stocking labels based on my previous experience. The only condition is that sigma of these probabilities should be 1. So, let us say I am assigning 0.10, 0.15, 0.15, oh, it is coming some additional points here. So, let me do the corrections. So, it is also let us say 0.15. So, this is 30, 40, then 0.20, 60, 70, 80, 90 and 10. So, it is 30, 40, 50, 60, 70, 80, 90 and 100. So, this is the total probability of my demand labels. Now, the cost price as we considered in the last case is rupees 1. The salvage value let us say introduced this time is 25 paisa. The selling price is rupees 1.50. So, now let us calculate the cost of overstocking or cost of excess and cost of shortage. So, cost of excess will be the cost price minus salvage value. So, 1 minus 0.25 that is your cost of excess or cost of overstocking. Cost of understocking will be the profit which you are going to have per unit. So, selling price is 1 rupees 50 paisa minus the cost price 1 rupee, that is 50 paisa per unit is your cost of shortage. Now, in this particular case we determine, if you see this particular value CS upon CS plus CE. So, this is a very important calculation, CS upon CS plus CE. Now, what is this? We want to select the stocking label, on the basis of this particular calculation. In our continuous demand case, this was giving the optimal service label. Now, here it is going to give us optimal stocking label. It is going to give us optimal stocking label in the discrete particular case, and this formula is being derived on the basis of that by stocking additional units. By stocking additional unit, the probability of demand is more than Q. Probability that demand is more than Q will be determined by this particular formula. So, the idea is probability that demand is more than our stocking quantity is CS upon CS plus CE. So, whatever will come from this particular calculation, that is going to maximize my expected profit. So, now for using this formula we need to do a bit more calculation here, and that is we need to calculate the cumulative probability here. We need to calculate the cumulative probability in this particular table, and here we will calculate cumulative probability in such a fashion that will give us the concept of cumulative probability. So, for that purpose we will not calculate the cumulative probability from top to bottom as we do normally in all the cases. Here we will calculate cumulative probability from bottom to up, because in all cases whether demand is 10 or 20 or 30 or 40, 50, 60, 70, you will be able to sell 10 newspapers. The concept is that the demand is of only 10 papers, you will not be able to sell more than 10 is 10%. But when you are selling 30 newspapers, when you are selling 40 newspapers, you have already sold 10 newspapers, then only you are selling 20, 30 or any higher label. So, by understanding that concept of cumulative probability, we will calculate cumulative probability in this particular case from bottom to up, and that is a very important point we need to keep in mind. So, my cumulative probability column is 0.10, 0.20, 0.40, 0.60, 0.75, 0.90 and 1.000. Now, I will calculate this value CS upon CS plus CE. So, that will be coming to be 0.50 divided by 0.50 plus 0.75, and that is going to be this calculation is 0.550 divided by 125 is coming 0.4. This calculation is coming 0.4, and here this 0.4 we will select that what is the immediately equal or higher number than 0.4. So, here this number is coming here. I have started seeing 0.10, 0.20 and this is 0.40. So, the label of 50 is that label of Q, it is that label of Q which is going to maximize my expected profit, which is going to maximize my expected profit. And now I can do this calculation if I repeat this data on my next slide, that we have determined that by keeping these different labels from 10 to 70 and different probability labels were there 0.10, 0.15, 0.15, 0.20, 0.20 and then we have 0.10 and 0.10. So, these are the different labels for demand 10, 20, 30, 40, 50, 60 and 70. Now, our answer came that we should stock Q equals to 40, that is going to Q equals to 50, sorry, Q equals to 50, that is the answer we got. Now, for this particular label, you can now determine, you can now calculate the expected profit. This is a kind of, you can say, exercise we will like to do, that what is the expected profit when Q equals to 50. Now, let us slightly change the data. In this particular case, my cost price was 1 rupee, I was having a salvage value of 25 paisa, selling price was 1 rupees 50 paisa. Let us see, there is no salvage value. If no salvage value, the cost price was rupees 1, selling price is rupees 1.50. So, your excess cost is rupees 1 only now. Shortage cost will be 50 paisa. So, you can calculate your new probability label, and using that formula CS upon CS plus CE, CS upon CS plus CE, you will have a new value 0.50 divided by 1.50, and this will give you 150 upon 0.33, 0.5 divided by 1.5, that is 0.33. So, again almost you will have the similar label of stocking units because of the arrangement of these probabilities in such way that again you will stock 50 number of units. So, point which is there, point which is important to understand, that we need to develop the labels at a close interval. If you want to have a better inventory model in this particular case, you need to have, like in this particular case, I have inventory labels, stocking labels at a gap of 10 units. If I have more closed inventory labels, if I have 10, 12, 14, 16, 18 and so on, I will be able to take a better decision with respect to my stocking quantity, because that will give me closed answers. Here I will be taking an answer at an interval of 10 units. So, which can drastically differentiate between my stocking values. The other important thing is that how I am having the salvage value, whether the salvage value is there or not. So, that is also going to affect my decision. The third important thing, so now for discrete events, particularly in single period case, we need to have close inventory labels, inventory steps. So, that means at smaller intervals. If you have bigger intervals, you will not be able to take better decisions. Second thing is higher salvage values will help in stocking more units, and therefore, your expected profit may also increase. If you have no salvage value, so your risk of overstocking will increase, and that risk of overstocking will reduce your potential of stocking additional units. So, that is also a problem. The third is, you need to see that there is some use of leftover products in other parts, demand, equipment, etc. This will further increase your ability to stock more units. If you recall, in our previous class, when we started development of this model for inventory management for single period, we discussed that there is no use of these items which we are procuring in single period for any other period or for any other equipment. But if we can, because always we need to apply scientific model, scientific management systems, and we also need to customize those things in our working style also. So, if we are following this single system model where we have only single opportunity, we also need to see that how best we can use this model. So, more you stock, more expected profit is possible in case your service level calculation allows. Now, how that service level calculation will allow it? When your cost of overstocking is going down, when your cost of overstocking is going down, because if you see in the formula, everywhere this service level calculation, the cost of shortage is at the numerator, and in the denominator we have this excess cost, cost of overstocking. So, we can think of how to reduce the cost of excess, and because you cannot increase this CS, this is not in your hand. So, because the revenue, the price which you are charging, that is market determined. So, you cannot charge extra price, you can only reduce your cost of purchase, so that may give you additional margin. But the more important thing which can help you, that is the cost of overstocking. If you can reduce your cost of overstocking by multiple ways, so it will be against the assumption of our single period model, but it can help you in reducing the cost of overstocking if you can find some alternative uses of leftover periods. And therefore, the concept which is not the part of this discussion, but the concept of circular economy is going to be very useful, where whatever is left over is going to be used as input for some other purpose, and that way our salvage value is sufficiently high, and when salvage value is sufficiently high, we are having lower values of cost of overstocking or cost of excess, and that will help us in improving our service levels, that will help us in stocking more units, and by that we will be able to have higher expected profit. So, this is how the use of this single period model is not just limited to this mathematical calculation, but this is also helpful in developing and designing the overall strategy, that how the leftover of one particular thing will be used as input to some other process or some other equipment. So, we need to have a larger vision. Considering the current scenario, we need to have a larger vision for using these type of concepts in our industries, so that the profitability, the competitiveness of our organizations can be increased. With this, we come to end of this session. Thank you very much.